Good morning students of 9th standards. In the previous video we have seen theoretical part, that is postulates, theorem, again proof, direct and indirect proof. In that two are there, conditional statements, antecedent, consequent, Euclid's 5 postulates which are very important. This keep in your mind. Fifth postulate I told it was not proved. It is wrong somewhat. Today we will take the next part, that is a theorem. This is introduction to you. Structure is there of the theorem. Theorem means the statement what you have to prove. So its solution, how to write. First of all, first step comes given information. What is given in the statement, that you should write first. Then second comes to prove. What you have to prove, that you should write. Third, if needed, construction part is there, that I will tell afterwards. And then comes proof. You have to convince by your own words, logic, the statement you have to prove to the examiner. Okay. So today we will see the theorem to prove. So here see, the statement is there, the opposite angles formed by two intersecting lines are of equal measures. Two intersecting lines are there and their opposite angles are equal. This we have to prove. For that, figure I will draw. So here see, AB, line AB is there, then line CD is there. So we will see the structure. First of all, given information. What you have to prove in this is opposite angles are equal in this way. Given lines or line AB and line CD intersect at a point O. Now, what you have to prove in this? Already given in the statement. So practically how you show? Angle AOD is equal to angle BOC and angle AOC is equal to angle BOD. So here construction is not needed. So directly we start from proof. Always what is given to you, that you should write first. Line AB and line CD intersect at point O. Next, angle AOD plus angle AOC is equal to 180. Here equation 1 you can give, reason you can write. These two angles are adjacent and they measure 180, therefore angles in linear pair. Second, in the same way, angle AOC plus angle BOC is equal to 180. Same reason you can give, angles in linear pair. Now from 1 and 2, if you see, if A is equal to B and C is equal to B, like this is there. If right sides are equal, left sides are also equal. So this property applies. If right sides are equal, 180, 180, then you can say these two are also equal. So angle AOD plus angle AOC is equal to angle AOC plus angle BOC. In both, AOC is common. Again one example I will give. A plus 2 is equal to B plus 2 is there. You can cut this 2 from this, and what remains, what you will get, the result is A is equal to B. In the same way, therefore angle AOD is equal to angle BOC. Reason you can give, eliminating angle AOC from, or you can write this much. So first you got angle AOD and BOC. In the same way you will get angle AOC and BOD. So here I write similarly, angle AOC is equal to angle BOD. So we have proved this. Now indirect proof is there. In indirect proof, see on page number 10, statement is given to you: a prime number greater than 2 is odd. A prime number greater than 2 is odd. In this way it is given. Conditional statement they have given in that if p is a prime number greater than 2, then it is odd. So how they have proved the information, how they have proved this by indirect proof, see in the textbook on page number 10. Instead of writing, I will explain this. First of all, given information they have given, p is the prime number greater than 2. Okay, other than 2, greater than 2 means other than 2, that is 1 and p are only divisors of p. You know the definition of prime numbers. Prime numbers are those numbers which have only two divisors, 1 and itself. So 1 and p are the only divisors of p. To prove is p is an odd number. Now see how they have started. Let us suppose that p is not an odd number. What we have to prove? P is an odd number. But what he has considered? Let us suppose p is not an odd number. This is indirect proof. So p is an even number. If it is not odd, then it is even. So therefore, if it is even, then p has a divisor 2. Any even number is there, then it has divisor 2. But it is given that p is a prime number greater than 2. But they have told p is a prime number greater than 2. So therefore 1 and p are the only divisors of p. Statement 1 and 2 are contradictory, means they are not matching each other. What they have told first? That p is an odd number which has odd prime number which has divisors 1 and itself. And second thing what we have shown, that it is even, so it has the divisor 2. So these both are not matching. Therefore statement 1 and 2, or what we have considered first, that it is not an odd number, p is not an odd number, it is false statement. Therefore this proves that the prime number greater than 2 is odd. In this way, so simple it is. First of all, what information is given to you, that we have to consider as wrong. Then logically we should show that what we have considered wrong is false. If it is a false, then it might be true, the previous statement. So this is indirect proof. Tomorrow you will see practice set 1.3 and problem set 1. So thank you very much. I will stop today.